Hi everyone, welcome back. So for today, we are going to complete from where we started from. Just going to cancel out this. And looking at the courses that we've been doing since beginning, this is just still the first course, Google Cloud Fundamentals Core Infrastructure. So I think we've been a little bit slow, but I also like that we've been more like slow and steady. And I also want us to have a case where we understand. So we've completed 1, 2, 3, 4, 5, 6, 7. So we are left with developing and deploying in the cloud and logging and monitoring. So I would go over developing and deploying in the cloud. I would also skim over logging and monitoring. I want us to do the lab under this developing and deploying so that we can see how we can automate deployment using Terraform. I think it's something that's nice for us to see how it works. Some of you may have watched it from the videos that I shared, from the link to the videos that I shared, but I would also try to run over it on the call today. Like this. So for development in the cloud, so typically when developers, when they launch their application, Google Cloud provides an enabling environment to deploy or develop impressive application. And when those app is ready, typically when your application is ready, you want to deploy them either you want to deploy them to production, or you want to deploy them for staging or for people to test it out. So how do we deploy application after we develop them? So it starts from some of the services that are available on Google Cloud for developing and deploying. First one is the cloud source repository. Next one is cloud functions, and we also have Terraform. The cloud source repository is just like similar to GitHub, but it's on the cloud. Cloud function is an event-driven service that can respond to events. Terraform is more of like a platform for automating deployments on cloud. So it's not only on Google Cloud, but you can use Terraform to automate deployments on cloud providers typically. And let's first go over the development tools in the cloud. So like you said, we have the Git repository, which each of us all know, where you can run your own Git instance. You can also have a hosted Git provider. And how GitHub works is it's like a version control system. You can use it to store, you can use it to version your code, and you can use it to also manage your code. And you can integrate your GitHub account, or you can integrate your GitHub repository to cloud builds that can enable you to easily deploy your application using continuous integration and continuous deployment. So you can use CI/CD with the normal GitHub that we have, two cloud builds to just run your applications. But if you don't want to do that, if you want a managed application, so if you take a look at this, if you want a repository that's like private to Google Cloud, and that you have the required IAM permission to access your repository. So I also know that with the normal GitHub also, so you can make a repository private, and just people that you add to an organization will have access to it. So that also works with GitHub. But with cloud source repository, you can have more granular permission settings that people having permission to the organization does not necessarily mean they have a permission to a particular repo. You can even set the permission based on repository, something like that. So the cloud source repository is like, we can say it's maybe a managed deployment of Git on Google Cloud. So, and it provides the full featured Git repository hosted on Google Cloud, and it supports collaborative development of any application or services, or including those that you also run on App Engine and Compute Engine. And with the cloud source repository, you have this is the GitHub. From the GitHub, you have the Bitbucket, and you can also inculcate debugging and health reporting tools into the cloud source repository. So it helps to have a full version or a full features of everything. So when you're using the cloud source repository, you can easily debug can easily debug errors in your code during deployment. So as things are getting deployed on the cloud and any of them fails, since you are using cloud source repository, it can just point to you what actually got wrong that led to that failure. So it can help in debugging, error reporting. It can also help in tracing errors in your code. So many applications contain event-driven parts. So there are some times that you want an application to respond to an event. For example, let's say I want to download a PDF that gets saved to my drive. I just want to download it automatically on my device. So if I want to do that particular stuff now, I have to like create an event. So what the event is going to watch for anytime a new file drop on my Google Drive. So anytime a new file drop on my Google Drive, it's going to trigger the event. So when it triggers the response would be to download the file. So if I want to do something like that, then I have to use cloud function. And okay, before we go to cloud function, so these are just some things that you can. These are some of the things that are like events driven. Let's say you want to convert a file format, you want to convert a thumbnail, you want to convert to a specific thumbnail size, or you just want to store new files in different things as they drop on a particular server or as they drop on a particular system. So in that case, we want to use cloud function. Cloud function is really powerful and it's serverless. Serverless in the sense that you don't need to manage servers. So you just need to put your code in the form of an event, and when the event gets matched, it triggers it automatically for you. So with cloud function, you can write a single purpose function that completes the necessary image manipulation, and then arrange for it to automatically run whenever a new image is uploaded. So this is when, let's say you are watching for a new image on a particular server, where you can use cloud function for anything, not just image. You can use it for file or anything. And let's talk about cloud function. Cloud function is lightweight. It's an event-based architecture, and it's asynchronous compute solution. Asynchronous in the sense that it allows you to create small single-purpose functions that can respond to cloud events without the need to manage a server or a runtime environment. So imagine that it is when a file drop that I'm now going to my compute engine to go and spin up my instance before I can download that file. So in that case, it's a long thing. But with cloud function, anytime it matches the specified event, it just triggers what you want to happen immediately. And you can use this function to construct application workflows from individual business logic tasks. So it also gives an ability to create small single-purpose functions that respond to cloud events without the need to manage servers or runtime environments, like you said. You can also use this function to construct application from bite-sized business logic and connect and extend cloud services. So you can extend multiple cloud services with cloud functions. You just need to create a trigger in each and every of them. And when the event matches the trigger, it just triggers what you want to happen. And it is built to the nearest 100 milliseconds, and only when your code is running. So in this case, more often than not, you don't need to pay for it. Let's say when they say it is built to the nearest 100 milliseconds. So let's say you just use your cloud function for less than the seconds. You only need to pay for the nearest 100 milliseconds. So that's something like so you may look at it that, oh, I could have just paid for a second and not pay for 100 milliseconds. But in when you look at it in a large scale, you see that it's also an increased benefit. You know, some things typically they'll just bill you per second. They're not going to bill, they're not going to go granular on milliseconds. But with cloud functions, you have more granularity on milliseconds. And it supports writing source code. I'm coming. So supports writing source code in a number of programming language. Like you can run your Node.js code, Python, Golang, Java, Netcore, Ruby, and PHP. So it typically accepts a whole lot of the popular language that you can use for software development. And events from cloud storage and PubSub can trigger cloud functions asynchronously or use HTTP invocation for synchronous execution. So this is just still re-emphasizing on the event-based architecture of cloud function. And anytime something that matches your event happens, it just triggers what you want it to do immediately. So creating an environment in Google Clouds can mean a lot of work, like setting up complete network, storage resources, and keeping track of all those configurations. But if you want to design a way whereby we can automate deployment, or we can automate deployment of infrastructure by just editing our configuration files, it makes a whole lot of sense. And the tool that we can use for that is Terraform, and that's what we are getting into in a bit. So you can just easily update command if you want to change the environment, and you can write new command if you want to clone an environment. So this is where Terraform works. So with just different templates, which are like configuration files, you can use it to create a complete engine instance, you can use it to create a firewall rule, you can use it to create a whole lot of resources just by having configurations and editing those configurations. So I would make sure we do a lab on Terraform today so that we can see how Terraform works and how it can also help us to easily configure informations or configure resources. So typically, you create a template file using the HashiCorp configuration language that describe what the component of the environment should look like. Thereafter, you now use that template to determine the action needed to create the environment the template describe. So you can also use Terraform to update the environment to match the changes, and you can store and version control Terraform template in the cloud source repository. That's if you link it to the cloud source repository, you can also store your Terraform templates and version them when you need them. When you just need to make little editing, you can do that from the cloud source repository. And that's all on development in the cloud. So we'll do a lab on this, but let me quickly run over logging and monitoring before we start our lab. So I've more of explained what logging means. That logging helps us understand like the track of how people are using our services. So typically what logs means is if I create a complete engine instance now, there's going to be a log for that particular action that I did. It's going to say, oh, this particular user created a complete engine instance. So it's going to show the time. That's what logging means. But monitoring just means seeing how your services are running, or seeing maybe the health check of your service, seeing how your services are running over time, and spotting maybe where there's an issue, or trying to monitor the resources so that you are not going to go over your budget, or trying to monitor your resources so that when you meet up a quota, you can easily scale down, or you can easily be aware that, oh, I've met my quota for this month. So that's an idea of what monitoring and logging means. So let's see. No, this is a summary. Let me go to the login. This is the login to the login. Sorry about that. It's supposed to be the login. Oh, this is a whole lot. I don't want to go over 71 pages at the moment. But do any of us have maybe any major concern or maybe any major questions on that login when we check through the resources? Anybody? For those of us who have any of us checked through the login and monitoring slide to see if maybe there's any blurry part or any part that is not clear that we may want to go over. Okay, so I'll just see if I can skim through it very fast. This is still okay. So let's go to the login and monitoring. So monitoring is the foundation of product reliability. So when you can monitor how your product works, you know how reliable your product is. If there's no metric to monitor if my service is on at a particular time, then I don't know how reliable my product is. I don't know how reliable my service is. So monitoring reveals what is urgent or what needs urgent attention. It shows trend in an application usage pattern, and it also helps to improve an application experience. That's typically what monitoring helps you to do. And so there's a Google Site Reliability Engineering. So if you look at DevOps, developer operations, site reliability engineering, so they are typically very on top on monitoring and logging to see how their services are doing and what is the level of the reliability of their products or of their operations in a particular organization. So this is just from the Google Site Reliability Engineering books, and it basically works on collecting, processing, aggregating, and displaying real-time quantitative data about a system. So you can see some metrics like the query count and the types, the error count and the types, the processing times, or maybe a server lifetimes. So this SRE helps you to see all these things or helps you to uncover all these insights from your data. And with monitoring, it also leads to ensuring continued system operation. You can uncover trend analysis over time. You can build dashboards. You can alert personnel when system violates the predefined service level objectives. So let's say when a branch of the organization is doing lesser than their service level objective or their service level agreement, we want to call them into, we want to alert them that, oh, your service has been down for more than the SLA that we agreed upon. What's happening? You can compare system and system change, can provide data for improved incident response. So when things happen and you monitored or you saw what led to that particular error or what led to that particular traffic spike, you can monitor it and you can have a better idea of how you can manage something in that similar scenario. So, and this is an application client. This is how they see it. So there's products. So an application client normally only sees the public side. So typically, people just see the products. Just see the products. But in the products, a whole lot of things go beyond the products. There's a developing, there's capacity planning, there's testing, there is root cause analysis, and there's a post-mortem checks. There are incident response, and there are monitoring. And all this go a whole lot in building our application. So developers and business stakeholders both tend to think that the most crucial way to make their clients happy is by spending most time and effort on products. And sometimes that does not really work. Because if your product must be reliable, it has to like be reliable in all these stages also. It has to be very reliable in all these stages. From the developing to the capacity planning to the testing of bugs, testing of errors, to even going over the root cause analysis and seeing why something is failing or what is leading to a glitch in your system, and also how you respond to incidents that happens, and the general monitoring space at large. So all these are just to show the importance of each and every of these things. You can go over this document later. So that's for, and Google Clouds gives us some things that can help us to be on top of our monitoring. The first one is continual improvement. So there's data that you can receive from monitoring that you can use to see what is happening at a particular time. You can also build dashboards from monitoring and see an high-level overview of what is happening on your various services that you have currently running. You can also create automated alerts. So when you hit your target or when you hit your specified quota for a particular service, you can automate alerts to get sent to your email. You can automate alerts to get sent to your Slack or to any platform that are really integrated with Google Cloud. So there are a lot of third-party integrations or third-party tools that you can integrate with Google Cloud, and it's going to send your alerts to it. And there are also monitoring tools that can give you like an extra eye on how your services are doing. So it helps provide data crucial to debugging application functionals. and performance issues. So with monitoring tools, you can see your application with an extra eye and just have a way of knowing where the error is coming from without having to go to over a whole lot of code signals. And these are some four golden signals that can help us to determine how our applications are doing. So there's the latency, there's traffic, there's saturation, and there's error. So latency typically measures how long it takes a particular part of a system to return a result. So let's say I'm playing game. When I'm playing a game, and there's sometimes a lag between the audio of the game, or let's say the video part of the game and the audio part. For those of you who sometimes stream football matches, or even sometimes when you watch football matches for the satellite services, also like DSTV or sort of, you would notice that there are sometimes that there can be a lag between the video and the audio, or a lag between the audio and the video. Sometimes the audio may be faster than the video, and sometimes the video may be faster. Are you saying something? Okay. So sometimes the video may be faster and sometimes the audio may be faster. So these are just what latency can bring in. These are some of the things that are caused by latency. And how can we measure latency? So we can measure latency through some of these metrics. We can go over them at another time. So what is traffic? Traffic measures how many requests is reaching our system at the part. Traffic measures how many requests is reaching. Traffic measures how many requests is reaching our system at a particular time. And it is typically an indicator of the current system demand or an historical trend of, and it can also help to serve as an historical trend for capacity planning. And it is a core measure when calculating the infrastructure spend. So when you look at the traffic that you are receiving on your particular server, it can help you to plan. It can help you to see an indicator of what your system or what your server is currently running upon. And if you need to scale up, you can scale up before it becomes much of an issue. So here are some metrics that you can use to check the traffic in a particular server or in a particular system. So going to the saturation. Saturation measures how close the capacity of a system is. So it is important to note that capacity is often a subjective measure that depends on the underlying service or application. So what they are saying here is that how saturated your service is, it's a function of the underlying application, a function of the underlying service that you are building. So your service is, if your service is built upon a server which is very large, then the saturation level is going to be very reduced. So here are just some things on how you can measure saturation, and this is how you can also, these are some metrics that can help you to stay on top of your saturation, or that can help you determine the saturation level of your device or of your server. So what are errors? So errors are events that measure system failures or other issues. So errors are often raised when there's a flaw or there's a failure or there's a fault in a computer program or system that causes it to produce incorrect or unexpected results. So every one of us here probably know what error means. And it may indicate that something is failing. It may indicate that there's a configuration or capacity issue. It may indicate a service level objective violation. An error can also mean that it is time to send out an alert. So this is typically what error means. And this is how you can measure. These are some metrics that you can use to know that there's an error. This 400 error and the 500 code error. Some of you will have seen error 404, page not found. So those are some metrics that you can use to measure error, either on your web pages or on your application. And there's what we call service level indicator, a service level objective, and a service level, and there's also service level agreement. And all these things, they help us to have like a transparent interaction with our customers or with your other colleagues. So they know the amount of, they know how they can manage their expectancy rate and know that, oh, for this service, I know that there's a probability that it can fail 2 times in a day or 2 times in 24 hours. There's probability that it can fail for 3 minutes in a day. So when you make sense from your monitoring, it can help you set up all these service level indicator, the service level objective, and service level agreements. And each, more often than not, most organizations have this that they do share with their customers. So a service level indicator just means carefully selected monitoring metrics that measures one aspect of service reliability. So it's typically like showing service level indicator are sort of like time bound. So it is how the service or how the infrastructure is doing at a particular time. That can be as a measure of your service level indicator. So let's say what is the performance that we're having in each 5 minutes, and you can do that on a rolling basis. That's an idea of what service level indicator means. So number of good events or count of valid events, and it is typically calculated as number of good events divided by count of valid events. There's also what we call SLO, and SLO combines a service level indicator with a target reliability, and it's generally be somewhere just short of 100%. So that, for examples, you can have a service level objective of 99.9%, or some services that even have 9, they have 5 nines in their SLO. That's 99.999. So those kind of service, they'll be more reliable than an application that does have 99.9% SLO. And when you're also measuring your SLO, make sure that it is specific. If you want to make sure it's specific. You want to calculate the service level objective for a particular service, or for a particular device, or for a particular application. Make sure it is also measurable. Know what you are considering, and make sure that it is achievable, it is relevant, and it is time bound. So there are some objectives that may not be relevant. So let's say maybe I'm trying to check the amount of time that someone who purchases a DSTV subscription on their TV. So that may not be relevant to the DSTV provider. They are not really concerned with the amount of time that you are putting on your TV. They just want to make sure that their services are available to you at any time that you want it. Either I'm putting on my TV at 2 a.m., it should be available. Then I'm putting it at 5 p.m., it should also be available. So make sure that the SLO you are checking is relevant to what your customer needs. And it should also be time bound. So an SLO should be time bound and should have a time that you are considering for each and every of your SLOs. So there's an SLA. SLA is the one that most customers have for their services and products. That is the one that it is a combination of all these things that leads about the service level agreement. So this is the commitment made to your customers that your system and application would have only a certain amount of downtime. So when organization studies their server, study their application through all these things that I've mentioned, like the latency, the saturation rate, the error rates, and the fourth one, forgotten. And if you check those SLIs, the service level indicator, the service level objective, it can help you determine what you are going to write in your SLA, because those are what would make your SLA be truthful, and it will also lead to it will also lead to a situation whereby you are only promising what you can meet. So if I know that my service level indicator is very low, I'm not going to promise the SLA that is very high, because I know that I'm not going to be able to meet that particular service. I'm sorry, guys. I just want to lock my window. Okay, I'm back. So, and there are some things so SLA is just the minimum level of service that you promise to provide to your customers. And you would also tell them what happened when you break that promise. So you can decide to maybe refund them for that particular downtime that you're having. Because people are paying for your products. And anytime your service is down more than the amount of time that you've specified that is going to be down. Because when organizations who are really conscious of the amount of time that their servers are up, they will go over the SLA very well and make sure that anytime a company defaults their SLA, or they break the promise of their SLA, they can even charge them to court if they don't fulfill what they say they are going to fulfill. So if I say, oh, if if I break the promise of my SLA, I'm going to refund you for your downtime, or I'm going to pay a particular amount of money at a particular time. So, and that is what the organization or the business that is using your product at that particular time, that is what they are going to bank on, and that is what they are going to hold on to you. So, yeah, just some. So, the service level agreements are typically for paying customers, because when they are paying you, they expect a particular amount of service that you are also going to offer them at any time. And there's an SLA compensation for service outage. So this Honda alerting threshold, this is the SLA for the minimum level of service. So it's always good to keep your SLA at a minimum level. So don't keep your SLA to be too high. In the case whereby, let's say, I know that my services I know that my application may go off for 3 minutes. I know, like, let's say I knew that before. So a good practice is for me to keep my SLA to maybe 5 minutes or 10 minutes, so that more often than not, I'm not even going to reach the stage of 10 minutes. But like we know, it's a competitive world, and there are different service providers, there are different cloud providers. Some cloud providers, if you are trying to make your SLA very, very small, so that your customers will not be able to hold you responsible, then people can just easily go to some other cloud providers and use their services that are more reliable. So that's typically what you want to do. And so we have SLO here. Explain what SLO means. So I think you all can just go over all this to read about it and see how it really works, or some of the things that can help you in monitoring and logging. Because we're trying to be conscious of time. So all these things are they are very, very descriptive, and that's something that you can just easily make sense of. I want us to go to login at the very least before we continue, before we round up. So let's take a look at login. So there are logins allow users to collect, store, search, analyze, and monitor, or even go over the alerts on log entries and events. So there are automated logins. Automated logins are sometimes integrated into Google Cloud products like App Engine, Cloud Run, and Cloud Engine VMs. And you can even restrict the people that are even seeing the log of a particular application. So you don't typically want everybody in an organization to just see the log of what is happening in an organization. So some people should not be concerned with who does a particular thing or who did a particular thing. It's only those who are maybe in the operation side or those who are in the management side that should have an overview of what is happening within our projects and to be able to see all the logs that are going on. So that's so for cloud logging helps in log analysis. It uses Google Cloud Integrated Log Explorer. Entries can be exported into server destination, and you can even use pop-up messages to analyze your logs in real time. You can use BigQuery to examine login data through SQL queries. So you can even unlock insights from your login data by just writing SQL query on them. You can archive log files in cloud storage that they can be analyzed with several tools and techniques. So log files are typically typically files that you're not going to be checking every day. I don't need to check who did something every day. But let's say I want to check it maybe once a month. I can just archive those files in cloud storage, and when I just need them, or when I just need to check them once a month, I can just go there to check it. So when we talk about cloud storage, I mentioned the different classes of cloud storage that we have. I mentioned standard, nearline, code line, and archival storage. So typically, you cannot store your log files under your archival storage if you probably just need to check them maybe less than once in a year. So that's for that. And there's also a whole lot of things that cloud logging can help you to do in logins. So it can retain your log. There's also a data access log. It can be retained by default for 30 days. And you can also set the retention for up to 3,750 days. And there are some times that even those logs are required for compliance. So some logs are required for compliance, and typically you want to store them for a large amount of time so that they can meet that compliance regulation. So the log visible to you in cloud logging vary depending on which cloud resources you are using in your project or your organization. So, and here are some things, here are some types of logs. You have the cloud audit logs, you have the agent logs, there's also what they call network logs and service logs. And they differ in the type of log that they are going to show. So cloud audit log are typically who did what, where did the person do it, where the person do that particular thing, what are the admin activities that happen, what are data access, what are the system events, and what are the access to experiences that happen during that time. So if you are trying to answer all this information, you can come under your cloud audit log. When you go to the cloud, when you go to the agent log, it's typically concerned with different agents. So let's say the agent log uses like a Google customized and packaged Fluent agent that can be installed on maybe your AWS, Google Cloud, or virtual machine to ingest log data from Google Cloud instances. So you can use that to ingest log data to the agent log. For the network log, you typically can check the VPC flow, the firewall rules, and the NAT gateway. So and you can see that all these are typically related to network. And under the service log, we have the standard out and we have the error under the service logs that you can check. So they kind of like provide access to log created by developers deploying code to Google Cloud. So an example is the developer build a container using Node.js and deploy it to Cloud Run. So any login to standard out or standard error will automatically be sent to the cloud login for easy or centralized viewing. If did it work or was that an error, it's going to just throw the log on a particular service to where you want them. So that's what logging does. And how this monitoring, logging, error reporting, and debugging, they are under the Google Cloud Operations Suite. When I open my my console, I'm going to show you the Operations Suite, and we are going to see the various services that we can do under monitoring, logging, error reporting, and debugging. Just do an high-level overview of that. So there's a part of error reporting, there's a part of cloud trace that you can trace where a particular error is happening in your code instead of just going over it haphazardly. So there's a cloud profiler. So I think most of the things are quite easy to understand, and you can take it, you can read over them at your leisure time to see some of the core capabilities of logging and monitoring or the operation suite on Google Cloud in general. So that's regarding that. For those of us on the call, when we went over the quiz that we used, did we have any issues, or was there like any part that was not clear? Do we need to go over the quiz, or we should just go over the lab now? Which one do you guys think? Please make your suggestion.
Let's just do the lab.
Okay. Yeah. So regarding the quiz, you can, if you get anyone wrong, you can copy a keyword from the quiz or from the quiz and just paste them here. So let's say there's a part talking about logins. There's a question talking about logins, and you want to see where logins is. You can just search this document and go to logins. Then you see where everywhere login is there, and through that you can easily see the correct option to that particular question. So that way you can go over the logins. So let's do the lab under developing and deploying in Google Cloud. I'm not sure there's a lab under logging and monitoring. There's no lab here, but there's a lab under automating the deployment of infrastructure in Terraform. So it's a quite interesting lab, and you'd see some of the things that we cannot easily automate with Terraform. I'll explain what Terraform is. That Terraform is used for automating deployment on Google Cloud. So it's not only on Google Cloud. Terraform, Terraform can also be hosted or on AWS or Microsoft Azure. So Terraform is like it's a third-party app from HashiCorp that you can use for automating deployments of infrastructure. So let's see how we can automate the deployment of let's say we can automate the deployment of infrastructure using Terraform on Google Cloud. So as usual, start my lab. Let's put this guy somewhere here. Okay. Quota exceeded for this lab. Oh, that's an issue. I have to tell them to refresh my quota for me again. Yeah, so if you have any question, you can ask a question now. And let's hope they respond as soon as possible. Okay. Yeah, so any question, anyone who has any question? I'm yet to work on any lab. Why? Why are you yet to work on any lab? Yes, you can still work on your lab. You can work on your lab. As far as you have credits, you can work on the lab for sure. So the labs have been here for before this. The lab has been there before the bootcamp, and it will also be there after the bootcamp. So, okay. What's this? This response is not. It's not syncing with what I want. This probably an automated response. I'm not sure a customer service person has joined this chat. So when they join the chat, you would see that, and the response should make sense. This response is not looking like it's coming from a human. So for those of you who joined late, I talked about this SSA Student Summit. So it's something that you all want to jump on. You are probably headed from it through your GDSC, but it's something you want to jump on. I'll share the link to the group, to the chat. So there are a lot of fantastic speakers that are going to talk, and there will also be a career panel on cloud. So you may want to listen in, and there's also a part for technical recruiters. If you want to see how Google kind of like go over CVs or try to see how Google do their recruitment. So you may want to join this session. So all the sessions they are been very fantastic that you would more often than not gain from. So do well to join in. And all this will be happening simultaneously. All this career panel will be happening simultaneously. So if you're excited about machine learning, we join the machine learning one. If you're excited about Android, join the Android one. If you're excited about cloud, you join the cloud one. So I think everybody here will be excited about cloud. Me too. I'm very excited about cloud. So I'll be joining Chuka and Ezekas. And so you can also go over these learning resources. So there's an opportunity to get a certificate of completion, and there's also an opportunity to get a gift card from Google. So, and all you need to do is register. You can complete this quest under this beginner quest. So there's a quest here, and you just require 5 credits to complete that quest. So all these labs are quite simple. That you can this is the first lab that we even did the other time. So you can easily complete all these quests. They're quite easy to get started with. And after you've completed it, you just need to share the link to the badge that you get, and where you can see your badges. After you've completed this thing, your badge is going to show under your profile. So your badge is going to show here. So, and let's say, let me look for my badge under this part. The badge on this course, it's essential or something. Come in. So this is it. You just have to like maybe share, then you copy the link. After you copy the share link, then you have to fill a form so that you can be eligible for this certificate, and if you are lucky to be among the top 100 participants, you can get a gift card from Google. So you probably have to submit, you have to fill this form. There's a form here that you have to fill. So fill the form, and paste the link to the badge here, something like this. Paste it there and submit. And I'm hoping to see you all among some of the top 100 participants that would come out from this. So, like I said, these labs are typically very simple. If you are running, if you are running into error in doing any of them, you can reach out to me and I'll be happy to help you along the line. So you can get started with this as soon as possible. The deadline is March 19th. You can begin now, but the deadline is March 19th. So probably still have like 9 days. Okay, let me
Okay,
see.
let me see.
So you can
Sorry,
mute.
can you?
Oh, this thing is taking a whole lot of time. Or it's supposed to take a whole lot of time like this. Okay. Any other question? Uh, can you recall where we can get the badge? Okay. So, please, anytime you do something on the chat, you can just raise your hand up so that I can be aware that there's something on the chat box. I typically do not check the chat every time. So, but for this, to check your when you complete. So when you complete a particular quest, I'm just going to go back to. I'm going to go back to that quest. When you complete this quest now, so I've completed this. I've completed it way before now. So when you complete a quest, you are going to see that you've completed everything that is there. And meaning of completing something means just doing all the lab that are there, that are under this session, doing everything that is there. So there is 1, 2, 3, 4, and 5. So when you complete those 5 labs, it's going to show that you've completed it. And to see your badges or to see your badge, go to your profile. So when you go to your profile, there's a path, there's an activity, and there's a badge. So when you click on the badges, it's going to show you all the badges that you've completed, and you can share the link to a particular badge. If this is the badge now, I'll just share the link to this badge. I'll copy the link and share it. So that's how it works. Does that answer your question, Messi?
Yes, they were going to paste the link on the other page, right?
Yeah, I'm going to paste the link on the sheet. So there's a sheet provided by the team. So you can see it here, fill out this form so that you can receive the certificate, or you can even become among, you can also be among those who are the top 100, top 100.
Okay, thank you.
Okay, so that's regarding that. Let me share the link to this one also. Okay. More people should be fast. That taking a whole lot of time. Yeah, please, sorry for the delay. Any other question? I just want us to do it so that you can see firsthand how Terraform works. But it's a really great tool that can help in automating deployments of your infrastructure or of your services on Google Cloud. Anyone who has any question? While we wait for the Cloud Skill Boost customer support. Okay. Yeah, sorry guys. Yeah, so they are done and I can have access now. So probably have to respond to all that. Okay. Okay. So then as usual, we'll open our lab in an incognito window, then copy your password. This is my password. So after copying your password, yeah. So this is the dashboard of the this is the dashboard of my project that I'm going to be using for this lab. So to get started, all this we've done them. So to get started, the first thing we want to do is we want to activate our cloud shell. So typically, Terraform is automatically installed on Cloud Shell already. So you can just check for the version of Terraform that it's on the Cloud Shell. And it's supposed to be updated also because the Google Cloud Shell team will typically update the Terraform package on the Cloud Shell regularly. As new updates comes out, they are going to like update it. So you can see that in this place, I'm not running any Terraform install. That is because Terraform is pre-installed for me on my Cloud Shell. So to activate my Cloud Shell, I click on this and activate my Cloud Shell. Yeah, so got it. Then I'm going to run the Terraform -on command. And here we are. This is the current version 1.3.9. And you can see that at the time that they edited this lab last, it was 1.3.3. So which shows that we are still very updated. So this MKDR, for those of you who are familiar with Linux command, so MKDR means to make a directory, and the name of the directory we are making is TFINFRA. So TM, I probably can't pronounce it. So just TFINFRA. So that's the directory. And what a directory means is like a folder. That's what the directory means. So I'll run this command. It's going to create the directory for me. And after I've created this directory, then I can open my Cloud Shell. So there's an editor with Cloud Shell. This is the Cloud Shell editor. This is the terminal. This is the editor. So most of the configurations, since we want to change configurations, we'll be setting those configurations on our Cloud editor, on our Cloud Shell editor. When we want to run those commands, we'll be running them from our Cloud Shell. So I'll just open my editor. Let's wait for it to initialize my editor. Taking time. I probably know it's not my service. Just them. Taking time to just them set it up. Just before us. We'll have to wait for it till it's done. So that's going over the instruction. Like, let me just keep explaining the instruction for you. And when our Cloud Shell editor is done, you all will see that we would have a TFIN FRA folder. We'll have a folder named this. And why we're having that folder is because we created the folder through this command. Oh, still running. Still initializing. Okay. And looking at this, so we'll create under this folder, we'll create a name file, a provider.tf. And provider.tf, it will contain some of the configurations that would show us the provider of this service. And in this case, the provider is Google. So it will be a provider of Google, we'll put it there. Then when we want to configure some of the resources, we'll do that in another configuration file, which is, we'll name a configuration file mynetwork.tf. So .tf is the extension for Terraform, and this will contain the resources that we want it to get created, the resources that we want to create, and the properties of those resources. We'll specify them in this mynetwork.tf files. And let's see if we are done. Okay, so we are done now. We can open in a new window. So when you open in a new window, if you open your editor here, so it's for our editor to open. And this is it. So this is the CFI and FRA that we created. This is the folder. If I delete this folder and I run it again, you'd see that it's also going to get created. So let me just delete it and run it again. So you all can see that it's not there. Let me run the command once again. It's our Cloud Shell. So this is our Cloud Shell. We'll open our terminal back, our Cloud Shell terminal. When I run this command again, so let's go to our Cloud Editor and see it there. So when if you can see, it has come back there, and it can refresh to be on top. So let's keep going. So the next thing I want to do is, inside this folder, I want to create a file called mynetwork.tf. So you can create it manually. I'll create this one manually, but there's one. When I want to create the next one, I'll just use the command line to create it. So I can go inside this folder now. When I'm in this folder, when I just click on it, when I double click on it, I can create a new file. Then the file is named, I think I skipped something. The first one is supposed to be provider.tf. So let me name this provider.tf. And this is it. I skipped this. It's supposed to be provider.tf. So, and I'm going to paste this code here into my provider.tf. Now paste it. So typically it's saved automatically. It's supposed to save automatically. You can see that before you were seeing something like 1 here. That is to show that there was one unsaved something. But now it's not more showing. This stuff is stopping. Let me quit. Okay. So it will save it automatically for you. But if you want to be double sure, you can save it again. So after you've saved that file, then we now want to cd into the directory. So we'll cd into the directory, then we can run the Terraform init. So when we run the Terraform init, it's going to initialize Terraform for us. We'll run this Terraform init a couple of times, but let's just take things slowly. So I can first cd into the directory. We'll connect to this. I can first cd into the directory, and this directory is tf and fi. After, so you can see that I'm in that directory now. So then I'll run the Terraform init command. So when you notice that your Cloud Shell is doing something like this, you can see that it's not following it's not showing in the right format. It is going to write it here. what you can just do is that you can refresh your browser. So when you refresh your browser, it's going to, when it comes back up, it's going to take the expected format. So let's see. You can see now it's taking the expected format. Terraform is double R, not two R. Terraform, it's when I run the Terraform init command, you can see that it's initializing my Terraform. That's initialized my Terraform for me. So let's keep going. And you can also see the version. So version 4.43.0. Let's see the version that is here. So this version here is 4.56.0. That's the Terraform of for the provider that we are using, which is Google. Okay, so that's fine. So the next thing I want to do is I want to create this file. The name of this file is my network.tf. So, you know, I mentioned that you can create it in two ways. You can create it by just coming here and create a new file like we created for this one. But let me use the command line for this so that you all can also get familiar with some Linux command. So this is the directory that I'm in. This is the directory that I want to be in, which is, so I have to first cd into that directory. Let me first cd out. If I cd out and I create a new file, so the command to create a new file is touch. So let me say touch. Let me copy the name of the file from here. So you see that when it's going to, the file that is going to get created when I run this command, it will be outside the directory. But we want the file to be inside the directory. I just want to do this just for us to see how it really works. For those of us who are just getting started with Linux. So when I run this command, create this file. When I go to my editor now, let's go to my editor. You see that it's going to create the my network file, but it's creating this my network file outside this directory. So when I close this directory, you can see that this stuff, it's outside this directory. But anything we want to create it inside this directory. So I just delete this guy. And then I'll cd back into the directory. So to cd, I'll cd back into, let me just copy the code here. So I'll cd back into this directory. After cding back into this directory, then I can run the touch command. When I run the touch command, it's going to create the file again, and it's going to create it inside the directory now. So when I open my directory, I can now see the my network.tf inside this directory. So that's about directory or folder in when you're using Linux commands. So let's keep going. So this is where we'll copy some of the configurations of the network that I want to get created. So we're going to copy this. When I copy it here. So just it's showing an error. I know why it's showing an error. I'm supposed to replace this thing with something else, but I'm going to replace it in the next stage. So as you can see in my network, you're supposed to replace this resource type with Google Compute Network. So this Google Compute Network is telling you that it's telling the Terraform code that the type of resource that we want to create is what is a Google Compute Engine network. We want to create a Google Compute network here. So I can just copy this thing here. So depending on the network that you are going to create, there is the equivalent of the name on Terraform that I'm going to use. So when I want to create a Google Compute network, I'll use this one. And that is about that. So the Google Compute network it's a VPC network. So it means that we want to create a VPC network. And before we run the command, let me just show you our VPC, and you will see that our VPC is not having what we are going to create at the moment. So when you check our VPC, we should only see the default network. So for those of you who were on the call when we talk about networking, so I told you all that anytime you launch a Google Cloud project, it's going to come with the default VPC network. But when I eventually run my command, or when we eventually run our Terraform, you see that a new network will get created here, which will be different from this one. So let's just keep going little by little. Okay, we are here. So also I want to add auto create subnetwork. So I want the VPC network to automatically create subnetwork. We have to just paste it here. And so all these things that we are creating, there are some things that you specify when you are creating those services originally. So if it's that I wanted to create a VPC network originally, when I click on create VPC network, you'd see that there's a path for creating my subnet creation mode. Do I want a custom or do I want an automatic? So if I had not specify, it will just automatically pick custom for me. But since I've added that that line that the subnet creation mode should be auto, so it's just going to do that. So all these typical things that we are going to like individually put here are all what will be put in on our configuration file to create our VPC network. I'll just cancel out of that. Come in. Okay. So after that, it should look like this, and you can see that our my network also look like what we have there. This is it here. It also look like what is here. Then after that, you save. It has saved automatically, but you can press your Ctrl S if you want to be very sure. So after that, we want to configure our firewall rule. So we want to allow HTTP, SSH, RDP, and ICMP firewall rule. And to do that, under our network again, we would also specify for the firewall rule. So just below it, paste this command to add the firewall rule. And we'll change this. Don't forget, I will change this to the name for the firewall rule. So when we want to do for firewall rule, it is what? It is called rule complete firewall. When we want to create the VPC network, it is called rule complete network. So for firewall rule, it is called this one. So I'm going to change this to this that is here. So if I'm rushing too much, please just call my attention. Okay. So here also, okay, I'm supposed to change the resource name to something for the first one. Okay, the resource name here should be my network. Let me just change the resource name also. So this resource name would be the name that would show on the VPC network that we get created. So let me see the resource name for the firewall rule. It wants me to use the resource name of this from here to the end. Just copy this. You can typically use any resource name you want, but just make sure that the name is quite descriptive, so that you know what the firewall rule is working for. Because you can have multiple firewall rules across multiple VPC network. Okay, so we've done this. We've added our firewall rule, and the next thing we'll also do is we'll add the following property to our network. So the property that we are adding now, the function is to make sure that the firewall will depend on the network that we are using. So we are saying that this firewall rule should depend on the network that we are originally creating, and that is what we are using the rule complete network my network.selflink. So this firewall rule that we are creating will be dependent on this network that we've created above on top. So just add this here. And if I also show you if I show you how you are going to create this originally on the console, you also notice that we would specify where the firewall we want, where the firewall we are creating, we'll specify what we want it to do. Because if you look at the firewall that are here, you see that all these firewall they are linked to the default network. They are linked to the default subnetwork. So the one we are creating also should be linked to the network that we are creating at the moment. So that's why we are adding this. So please make sure that you are as careful as possible when you are doing all these configurations, because when you run into an error, it may not deploy. So I'm also going to add the necessary ports that I want. So for the TCP protocol, I want a port 222. I want a port 2280 and 3389. For the ICMP, I want the 0.0.0.0/0. So all these are just protocols and ports that we are using. So make sure you specify everything on your configuration files. So our configuration file should not look like this. So if we take a look at it, it also look like this. And if you are unsure, you can just easily copy everything here and just replace it with what is here. But it's probably the same thing since followed all the steps 5, 6, 7. Yeah, so I think we are good. I think we are good. So then we'd save it also. It has automatically saved. So thereafter that, we also want to create a new file. And this new file I want to create, we'd name it instance. So to create a file, I want to create a folder rather. We first create a folder, then we'll create file inside folders. So who can tell me the command to create a folder in using Linux command?
Create folder can be CD
No. So create a
or make
folder.
MK.
Is that MKDIR? Yeah, MKDIR. So look at it. The instruction is that inside the TFINFRA, we should create a folder inside this folder. So we are creating a new folder inside this TFNIA. So if you want to do that, you can do that in 2 ways. You can just do that by just doing like this and create a new folder and name that folder the name. But let's use the command line. Let's use the command line. So I will get familiar with it. Let me connect to this. So I'm already in my directory. I'm already in this directory. So the next thing I just need to do is this. I need to run my mkdir. Then what I'm creating now is different. This is what I'm creating. Creating an instance. Let me refresh this so that if I'm doing the expected stuff. Looks like we'll stay a little bit long on this call. I'll try to move fast also. Yeah, but it's the weekend tomorrow, so probably can enjoy. So I'm just trying to see if there are not much space here. Okay, so this is the folder I'm creating, and I want this folder named instance should be under this this particular folder here. So when I run it, then we can go back to our editor, and you'll see that this instance has gotten created under the what? Under the TFINFRA folder, which is what we want. So, and the next thing is also that we want to create a file. We want to create a file inside the instance folder. I want to name the file main.tf. So, who can tell us the command to do this with Cloud Shell? To create a file.
Touch command. Use the touch.
Yeah, touch command.
The touch command.
Yeah. So, but if you run the touch command now, it's going to just create that touch. It's going to create it inside this TFINFRA. It's not going to create it inside this instance. So what you want to do is that you would cd into instance again. The instance that you created, you cd inside. So when you cd inside, you can now see that we now have 2 parts. We first have the parent folder and we have the child folder inside. So then you can use the touch command and the name of this one that we are creating, main.tf. So, and you can see it here. You can see that the main.tf is going to get created under the instance folder and not just directly under the TFNI FRA folder. Okay, which is fine. So let's paste the resources that we want under the main.tf. So why we are creating a new instance is that this folder now, all the configurations that we are going to put under this instance would be towards creating a virtual machine instance. You know, before under the TFINR, we created the VPC network and we created the firewall. But under this instance folder, the resources that I want to configure under them is towards creating a virtual machine or towards creating a compute engine virtual machine instance. So I'll paste this command. And when I paste this command here under the main.tf, and don't forget, I'll change this resource type to the resource type for creating a virtual machine instance. And that's just Google Compute instance. So the names are quite descriptive, as you can all see. So the Google Compute instance, I'll replace this So that Terraform is going to know that, oh, what I want to create is a Google Compute instance. So here, and I'm also going to name it. What name do you want to use here? Why might keep coming here? So the name we want to use here is, we want to use this one. So what this really means is that we are setting this as an environmental variable. We are setting this as a what? As an environmental variable. So we would specify this name in another folder under the variable folder. When we get there, I'll reference to it. But let's just template. So what we are kind of like doing here is that we are templating the value that is here. We are templating it. So this is not the value that you would see. This is not the value that you would see when it get created, but it's a template of the value that we are going to see when it get created. When we get there, out and also make reference to it. So let's add the following properties. When we are typically creating a virtual machine instance, we typically select the name, we select the zone, we select the machine type. Let me just show you once again. So when you want to create your virtual machine instance normally on Compute Engine, like using the console, you would see some of the things that we are going to do. So when you can see that the virtual machine is empty now. So let me just do as if I'm creating one. I'm not going to create it, but so you can see the name. We'll specify the name. We'll specify the region and zone, and that is why we also need to specify the region and zone when we are building the configuration file. We also see that we need to specify the machine type. So we'll specify the machine type along the line. So it's just typically something that you need to do here. You also have to specify in the configuration files that we are going to use. So let's keep going. So let me input my zone. I'm also using this as an environmental variable. I'm templating it. So all these templated values, I'm going to specify them under my variable folder. Let's keep templating it here. Then also we'll add these properties to the. So this is property that we are choosing the disks that we are going to use for our virtual machine. If we take a look at this thing that I showed you before, so there's a part that we are going to specify the boot disks. So you can see this boot disks. We can change it to the boot disks that we want. So you would also specify a boot disks here. So on this one, let me just specify our boot disks. Is this supposed to be here or coming? Let me copy the instructions. Okay, just paste it here. And after that, what else? So what we are saying is that I should use the Debian 11 operating system, and also have the network interface that we are going to use. So typically, before you can create a virtual machine, you have to have a VPC network. I think in the first lab that I did on this call, we showed that before you can create a virtual machine, you have to create a VPC network. And that is why this virtual machine will also pick the network, the VPC network that we are supposed to create in the first step. We are automating, we want to create everything at a go. So it's also going to make sure that it creates the VPC network first before it now creates this virtual machine. So that's why I'm also templating the value here to talk to that particular VPC network that I've created above. And sorry, it's this here for the network interface. So those templated values, you are going to like see them in the coming steps. So just take a look at all these things. This is how it should look like. And if you see everything here, it's also like it's like a dummy of this one. There's something that I think I'm missing. I'm missing this. I'm missing another something here. I probably missed the positioning of the coily brackets. I'm just going to replace that 1, 2, 3. So I have 1. Coming out 1 here. This one. Okay. Source property. Something zone after name. Okay, yeah, I see. So this thing, this enclosure is supposed to be downwards. We're going to take it downwards. Hey, no. What am I doing? I press Ctrl Z. Okay, sorry. I've deleted that, I'll just copy it again. So this is the step that I'm copying it. Copy it here. Then this is supposed to come here. So copy this one. This I can move this up. Then I'm going to enclose this guy here. So you can see this is enclosing this one. 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 And this is enclosing the full code that I ran. This one is enclosing the full code that I ran. So yeah. So it has been saved automatically, like I said. So the next thing we want to, and we can verify that it looks like this. We can verify that it looks like this. So we also want to create the variable.cf. So let's create this one manually. Don't let us use a cloud share. Let's create this one manually. So to create manually, the variable is also supposed to be inside the instance. So when I click on the instance, I can click on new file. Then I paste the variable.cf. Make sure you remove the comma that's there. And it's going to create the variable.cf file inside this instance. Then I can paste the command I want to there. So all those variables that I templated, this is where I'm going to specify their name. So this, someone raising up their hand. Oh. Okay, yeah, so let's keep going. So I'm going to specify. So all these variable names that I'm using, I also have to like specify those variable names. Then the next thing, so after this, the instance name, right? Okay. So this instance name, this instance zone, and this instance type, they would use what we've used in the default. They'll use what we used in the default. And we are going to add this. So this is the command that we're adding next. When we add this, it means that all these variables, anytime it sees all these things, it's going to pick the values that are here. But let's just keep doing it one by one. So I've inputted all this here in variable.cf. And next thing I want to do is I'll go back to my network.cf and I'll specify the values for all these variables. So you can see the instance name is going to use mynet_usvm. The instance zone is going to use this one. For the instance type also, there should be a part of instance type. We'll get there. So copy all this, then go to the mynetwork.cf. Paste everything here. So these are where we are just specifying the values that I should use here. Okay. So this is also leveraging. You can read over this another time. And for the instance network, we are asking it to self-link like we specified before. So we want this virtual machine instance to be created inside the VPC network that we've created on top. So like I said, there has to be a VPC network before you can create a virtual machine instance. Okay, so that's about that. So the next thing we also want to do is that you can now take a look at your my network and see that it looks like this. So I suppose mine should look like this. You can confirm. So you can see that it looks like this. So in this place, we are creating two virtual machine instances. So the first one we are creating is mynet US virtual machine. And the second one that we are creating is what? mynet European Union virtual machine, EU virtual machine, US virtual machine. So we would see both of them will get created. Let's keep going. Okay, so if you want to format your Terraform configurations, you can just run this Terraform FFmpeg. I'm not sure it's compulsory you do this. I don't actually think it's compulsory you do this. But let's just let me skip it for you. Let me skip it and see. But yeah, I'm not sure it's compulsory we do all this. I'm not sure it's compulsory we format this stuff. Let me see. So you write the Terraform configuration to a canonical format and style on the following command. I'm going to skip this, but if I run into error, then I'm going to use this. I don't think it's necessary to format it. Let's keep going. So after that, after we specified everything that we want here, we specified everything I want on the variables, specified all the things that we want on the main and the provider, then we can now go to our Cloud Shell command. We can go to our Cloud Shell. Let me refresh this once again. Then let's create all the resources that we've written the configuration files for. I'm going to leave here. So just for you guys to be double sure also, I'll show you once again that we do not currently have any instance created already. So you can see we have empty instance. We don't have any instance. And when I showed you the VPC, we only have the default VPC. So we are going to create a new VPC network. So you would see it also when we are there. So then run the Terraform init. So it initialize all the Terraform codes that we've written there. So after running the Terraform init, the next thing to do is to run the Terraform plan. So after running the Terraform plan, then you run the Terraform apply plan. So when you run the Terraform plan, it's going to show you an overview of the execution that you wanted to create. So all those files that we created, it's going to show us how it's going to create those files. So for the Terraform plan, that's the command, Terraform plan command. So when you run the Terraform plan command, see it here. Let's enter a value. Okay, it looks like it's taking me back to. Okay, yeah, I think it still works. So this is the instance. This is the virtual machine instance that we are creating. Let's see. Oh, this is only going to add one value. It's not going to add everything we want it to add. So I think I have to maybe run the formatting code to take the format that I'm supposed to take. Okay. No. So what's the issue? I'm not even sure that's the issue. So yeah, I think the issue here is that I'm running the Terraform init code inside this instance. So when I run the Terraform init code inside this instance, it's only going to take the resources that are inside this directory. Meanwhile, you know that it is only the instance that we created inside this directory. So the VPC network and the firewall that we created, it is directly inside this TF-INF array. So it is better we CD back into this TF-INF array, then run the Terraform init and Terraform apply, so that it takes all the resources in the folder. So it takes all the resources in the parent folder and not just taking all the resources in the child folder. So what it's currently doing here is that it's taking all the resources in the child folder, and the resources that we created in the child folder is only this virtual machine instance. So what I'm going to do is I'm going to CD out. So after CDing out, now CD back into my directory, which is this TF-INF array. Let me take a look at the instruction once again. Yeah. So let's see. When I CD back into this one. So for me, I can run the Terraform init. When I run the Terraform init, okay, there's an unsupported block file. So I have to format the code now. Okay, just going to format it. The Terraform format. Terraform format. Okay, so it has formatted it. So let's run the Terraform init once again. Showing an error. Terraform configuration must be valid before initializing. What's wrong? You coming? So I'm trying to debug this error. So this error is from the mynetwork.tf. All the error here are from the mynetwork.tf. So is there anything we are specifying wrongly, or have we skipped any step? Mynetwork.tf. Let me go over the instruction here. So we should verify that my network.tf looks like this. Quite sure it looks like this, but I can just copy all the code here and replace it with all this one and see if that works. It's going to get saved automatically. After it has saved finished, then you can run the Terraform format. After formatting it, let's run the init. Yeah, so that means there was something wrong before. That was wrong. Okay, yeah. So probably with the formatting that I used or how those codes were on those lines. So when you can just when you are doing it, you can make sure that you copy the code as it is showed on this instruction here. So there's probably maybe some indentation error in my code before, and that's why it screwed that particular error. Okay, so after doing this, after running the Terraform init, then I can run the Terraform apply. The Terraform plan first. So when you run the Terraform plan, you'd see an high-level overview of how it's going to create the resources. So let me show you. The first one is, you can see it's going to do the firewall rule. This is the firewall rule. It's also going to create the VPC network. Then it's going to create the instances. This is the first instance that's going to create this Minet EUVM. Then it's going to create the second instance, which is the Minet USVM. So you can see these are the resources that are going to get created. So after you've run the Terraform plan, then you now run the Terraform apply. So you just use the Terraform apply. And when I run the Terraform apply, I'm going to use an auto approve flag. So what the auto approve flag means is that it's not going to trouble me to enter a value like the previous time. It's just going to create all these resources automatically. So then you can see it's going to create all these 4 resources that we've seen here. So and going just following the instruction again. So there's a Terraform apply. After the Terraform apply, you'd have to run yes. So because I've used Terraform apply auto approve, I don't need to do any confirmation, and that is why I was not prompted to specify yes here. But if you want the Terraform apply, you'll be prompted to specify yes, and you'd have to like press yes. But when you add the flag auto approve, it's not going to prompt you to specify yes or no, something like that. So let's wait for our resources to get created. We're almost done, guys, and we'll see everything. Because I know it's almost a good time to round up. We are running 2 hours already. Yeah, so all these resources have been created. So let's say you're doubting Thomas and you're not very sure. You don't want to believe that all these resources have created. So let's take a look at all the resources one by one. The first thing is our virtual machine. Let's say our virtual machine. So when I refresh my browser, you can see the 2 virtual machines that we said is going to create. The Minet EUVM, the Minet USVM. It created both of them. Let's go to our VPC network and see the VPC network and the firewall rule that we asked it to create. So you can see before we only had the default. Now we have the My Network, which is the firewall we wanted to create. And if you go on other My Network also, we have different sub network here. These are the sub network that are under it. And if you go to the firewall rule, you'll see the firewall rule that we specified. So the firewall specified for the My Network is this one. So we allowed HTTP, SSH, and RDP, ICMP. This is the firewall rule. You can see that it is shown under our firewall. So yeah, so this is just to show that all the resources that we asked Terraform to create, that we automated the creation of all these resources, it got created for us. And typically, if you just need to change the name of the resource, you can just come here, alter this name. It's going to create a new one for you. You can come here if you want a firewall that is a little bit restrictive. You can specify what you want. If you want to change, if I want it to create another one of another instance name, I'll change the name here. I'll change the name here. Then I just have to run the Terraform initialize command again. After I run the Terraform initialize, which is Terraform init, then I run the Terraform apply. No, the Terraform plan. The Terraform plan will show me how I want the stuff to get created. And after that, I can run the Terraform apply auto approve. So that's typically all for the lab. You can check if you've completed this. It's going to give us a check mark because we probably won't spot everything here. And if you take a look at all these things that I showed you, so I've showed you the firewall rule, I've showed you this one. I've also showed you. So if you want to see if it works, if you want to see if you can connect to the internal IP address, let's just connect to the internal IP address. So let's connect to the internal IP address of the European Union own from the US. So what I'm going to do is that I'm going to SSH into the US virtual machine. So this is, let's go back to our page here. Go back to the virtual machine. Under Compute Engine, virtual machine. So this is the SSH part. And I'm going to SSH into the US own. When I SSH into the US own here, so since I'm SSHing into the US zone, then I have to copy the IP address of the European Union zone so that I can see if I can talk to it from the US zone. So paste it here. Then I have to replace this part here with the internal IP address of the European Union zone. Let me delete this and go copy the internal IP address. Oh. Okay, so where's our internal IP address? We are going to the internal IP address of the European Union. Since we SSH into the US zone, copy the internal IP address of the European Union. No, we SSH into the European Union own. So this is the European Union own. So I have to copy the internal IP address of the US zone. So this is the US zone. Copy it. Let's see if we can talk to it. And you all can see that there were 3 packets transmitted and 3 packets received, and there was 0 packets lost. So that is because we can talk to it. Why it's showing just 3 packets is because I limited it to just 3 packets by adding this 3. If I remove the 3, it's going to just keep pinging, continue pinging until I stop it. There's an extra space there. What's wrong? But yeah, I just have to ping. So you see that it will continue pinging till I stop it. So let me just stop it. Stop it. Yeah. So within that time, it transmitted 11 packets. 11 packets got received, and there was no packet loss. So that's for this, and that's typically the end of our lab. So you all can see that Terraform works, and it can help us to deploy different infrastructure, not only the one that we've done here. You can even automate the deployment of your database instance or a web server with Terraform. More often than not, you can automate deployment of any resources that you want on Google Cloud with Terraform. So thanks very much, guys. I think we'll end our lab here. Who has any question? Any question? Okay. You have a meeting by 10. Yeah. You've tried enough. If you leave now, it's a nice place to live. Who has any question along the line? No one? Who enjoyed the session? Yeah, you can ask a question. If you enjoyed the session, you can give a thumbs up so that I know that we are all on the same page. Okay, cool. Jessica, ask a question.
So, like when you are doing the lab, and maybe you get confused and stuff like that, and maybe end the lab. So the credit that you used to launch that lab is gone, right?
Yep, it's gone. What's
Okay.
it work? Yeah, so when you because it's provisioned the resources for that timeline, and even if you launch a lab and you could not finish that lab within the timeline, it's also gone. It's not going to mark it complete for you. It's going to mark it to the stage that you finished, that you left it. It's going to mark it to the state that you left it, but it's not going to give you like the full completion for that. But typically, most of the labs, even almost everything, the time are more than enough. And like you can even see, even with me explaining or doing something that I'm not supposed to do, I still had over like 12 minutes before the lab, before the time elapsed. So another question, guys. So there's something we are supposed to do for next week. I'm going to share the next course outline that we are going to do for next week to you all as an assignment that you can just start on that. But we've completed our okay, I'll leave this guy. Just cancel out of. I'm just trying to cancel out of our service. So since I've already ended the lab, it's going to automatically end my session also, and that's why it's bringing that pop out. So what else? What else? So I'm going to share the course content that we're going to go on for the next week. But it's probably on the syllabus that I shared with you all before, and you can just take a look at it there. Yeah. So please don't feel too much pressured, and if you are going too fast, you can also stick to your pace and make sure that to a great extent you know what we've done under Google Cloud fundamental core infrastructure. Make sure that you understand it to some extent, because I think the next course we are moving to is I'm not sure of the name. I'll confirm and share it to you all. I'm not sure of the name. So then let me guess. Yeah, so if there's no more question, we'll probably end here. Let me share the attendance to you all in a bit. Share the attendance now. Coming. Coming. Let me try to pick my attendance. Or does anybody have the link to the attendance? So the link to the attendance is not changing. It's still the previous one I've been using. See if I can get it here. It is not very far. Okay. Same. Yeah, so fill the attendance. But I typically know everyone who is even joining at this time. So because we've streamlined a whole lot. And we know now I can see that you guys are more of like regular on our call. And that also shows that you're excited about the cloud and you have more of like a soft spot for learning little things or for adding to your knowledge about the cloud. Yeah, which is great. Thanks guys for showing up. See you all on Monday. I'm going to share the resources that we're going to read up on Monday. But if you've not yet completed the first course, make sure you complete the first course very well before you move to the other one. Bye for now, guys.
Bye, sir.
Yeah, bye.